Nathaniel, you want to start the record?
There you go.
Okay, well, welcome to the November 8th, 2022 session of TangerineSDR and Hamside Technical Session. My name is Dave, KV0S, and this week I've been doing several things, but actually not quite as much radio as I'd hoped. Had to rebuild a couple computers, so that kept me busy. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. This week I've been focusing my efforts on the Solar Eclipse QSO party. So I wrote up the grant proposal for the NASA grant with the help of many of the people in the Hamside group that meets on Thursday afternoon, and with Gareth Perry's help and Joe Huba. And I think it's all ready to go for tomorrow. So I have it submitted to the university, and they're going to hopefully press the submit button tomorrow morning. So cross your fingers, we get another one in. And then I've also been doing a lot of work working on writing towards writing a paper for the NASA Living with a Star team I'm on as well, looking at traveling atmospheric disturbances. So it's all coming along. And Bob McGuire, N4HY, got to visit us this past Thursday and gave a talk on low-cost ionosons here at the University of Scranton.
Very good.
Very, very busy week. W2NF back to that.
Yes. Next on the list is Bill Engelke. Go ahead, Bill.
AB4AJ here. Well, I haven't done very much on the personal space weather project the past week or so. I've been focused mainly on the NASA project. I did get a new magnetometer in the mail from Scotty and got that soldered up. I haven't got it installed in the ground yet, but got that figured out. A little bit different design than what the older version that I have. So managed to install the PNI in there backwards because it is reversed from the older version. So anyway, but you pull it out and put it back, turn around and put it back in. So we'll have to make sure that we test to see what happens when somebody installs it backwards and powers it up, because people are going to do that, I'm sure. Anyway, back to net.
Very good. Next on the list is Michael, AAAK. Go ahead, Michael.
Thanks very much. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is Bob, N5BRG. Go ahead, Bob.
Yeah, hello everyone. Just wanted to drop in and see what's cooking tonight. I am working on antennas and hooking things up to try to be able to get my loop performance better, and for a SID monitoring thing. And I've got my meteor observing going here, and I got a computer that crapped out on me that I'm working on too, kind of like you are, I guess. And it seems like a never-ending problem, but have a lot of different projects in the fire here, and hoping to be collecting data. That's my aim here, to get data running and running constantly, so I don't have to be fixing things on it. So back to you.
Very good. Next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. Pretty busy over here. We've got a lot of projects, professional and otherwise. And I just found out that we've got a rocket shot that I'll be helping out with probably in July from Poker Flat, Alaska. And for the project, I'm working on getting a computer together with CentOS since last week. It came out that Intel's software doesn't work properly on various operating systems. So hopefully we can settle down on a given system and get this development going. And I'm looking forward to the total eclipse this morning. It's around 5 a.m. our time on this coast. Sets just as it comes out of totality, but maybe the rest, other guys further west will see more of it than we. Back to Nat.
Well, fine business. And next on the list is, let's see, David, KE5DPZ. Go ahead, David.
Good evening to all on the net. Not a whole lot to report here. We're worked on a couple of brew antenna on net last week, trying to tweak the, what the best kind of signal arrangement's going to be on them, and other with Raspberry Pi, which I'm not completely real familiar with. So I'm playing, but having a whole lot of fun and staying busy. Good to hear everyone on there. Hope every week does to do tomorrow. Okay, fine.
Well, very good. You had a few drop packets, but at least at my location, so just thought I'd let you know. Next on the list is Don, K1VX. Go ahead, Don.
Yeah, I've just kind of been poking around and listening in and reading some of the doc. I did kind of jump in a little bit. I ordered myself a Pi, so I should have that in the next couple of days. So to dust off my my Linux and get background from a few years ago before I retired. So hopefully I'll have that up and running in the next few days, and then I'm kind of trying to figure out what to do. Seems like kind of late in the project to build a Grape 1. I'd like to eventually end up with a Tangerine configuration. So any suggestions will be welcome. But do have some time and some space to play with things, and if there's anything I can do to help the program along, back to you, Dave.
Very good. Well, I'll have a suggestion here in a minute. Let's see. Next on the list is Dylan in KN6IVW. Go ahead, Dylan.
Hello, I'm Dylan. Hello. Nah. So nothing is really big going on, at least besides painting, but please forgive my brother in the background. And just painting and getting our house ready to put up for sale, well, get sold. And then once we do that, we'll hopefully be permanently in Tennessee for once. I don't have anything else, so I'll send it back to Net Control.
Very good. And next on the list is Hyomin Kim. Go ahead, Hyomin.
Yep. Good evening, everyone. I have been working mainly with Jules and David to collect more information about the magnetometer so that we can put everything together for publication. So Jules have provided like a lot of good information. So I'm still trying to digest those things. David said he will provide, still I'm waiting for his email information. So other than that, not so much going on in terms of magnetometer project. So back to Net.
Okay. Next on the list, we have James, KG4DSG. Go ahead, James.
Evening, Dave and group. A little busy this week trying to set up a local copy of the Ubuntu repository, and I'm having trouble getting the synchronization working. Other than that, not much going on. Back to the net.
Well, fine business. And next on the list, we have Jay, WB8 SBI. Go ahead, Jay.
Good evening, all my fraternal brothers in ham radio. Just getting and I'm undecided if I should or should not have that full strength coffee because the eclipse will be here in the Detroit area between about 0400 to 0700. So this is going to be a night of short sleep for me. I've seen one before several years ago down in Texas. So hopefully it won't be as good because I was in Booney Land there and I'm going to have the city lights to compete with it, but I'm kind of looking forward to it. Nathaniel, if you'll remember a few years ago, I gave a presentation on AMSAT. The guys from AMSAT Australia, I believe it was Oscar 5 or something, presented it to the club down there. If you'd like me to present that to the latest crop of students again, I would be available to do that at your convenience. You know, it's a 14-minute a film, if you remember that. So please get in touch with me and I'll be more than willing to coordinate schedules and present it to the club down there again. Other than that, that's about all from here. Hope everybody is well and staying safe. Back to Net.
Okay. Next on the list is Jim, K4BSE. Go ahead, Jim. Mike?
Yep, got it. Good evening. Not a whole lot here. I finally got a chance today for the first time to sit down and look at Nathaniel's application to NASA and stuff from where things were. Just as I pulled up the meeting this evening, sounds like I was too little too late as usual, but I did finally get through it. And let's see, we had the Atlanta Air Show here over the weekend, had the Blue Angels, and my daughter and I went to that on Saturday. It was a good show, even though they had to cancel a lot of stuff because of the clouds. It was a real cloudy day until late in the day, and that made them cancel a lot of the high stuff that the Blue Angels were going to do. But I still enjoyed it. Her house is right over the where the flight path, where when the planes fly off out of sight from the show, they fly over her house, that area. And my granddaughter said it sure scared her cat. Finally found the frequencies that they use for the air shows, but I didn't find that until after the last show yesterday. So next year I'll be able to monitor it some. That's really about all I've been able to do. Back to Net, K4BSE.
Very good. And next on the list is Joe, W7LUX. Go ahead, Joe.
Thank you, Dave, and good evening, everyone. We finished our last public service event Saturday and worked the group out in San Francisco that's a journey over to Angel Island and put on SOTA, POTA, IOTA, lighthouses on the air and boats on the air. Kind of a major ordeal. Our club president's son is the president of the San Francisco Astronomy Group. Anyway, we've also got the eclipse here, and the weather people have decided to be nice to us, so we might even see something tomorrow morning. The grape continues to plug along, and the solar activity has been much less during the last week or so than it had been previously. Haven't seen a lot of excursions or a lot of real hot flares going on. That's pretty much it, Dave. Thank you.
Very good. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It's been a little bit of a busy week. Last week, the Raspberry Pi 3Bs that I ordered from DigiKey back in the summer finally arrived, and I ordered these Raspberry Pi 3Bs at their normal cost. So I ordered two. One was to replace one I had, and the other one was for my 3-channel VLF system that I'm still in the process of working on. So I'm glad that they finally came. Also, I did a presentation at the local amateur radio club, the Murgosh Amateur Radio Club in Wilkes-Barre. I did a presentation on VLF, natural radio, and other sorts of VLF phenomena. Everybody really enjoyed it, so I was really, really, really happy about that. And I introduced VLF amateur radio, or at least talk to the group, and I hope that we can do some VLF amateur transmissions one day. Lastly, I was working on the backup, or the archival and backup of the recorded VLF spectrum data coming from my VLF system that's installed at Nathaniel's house. So what I was able to do with the help of Rob Wiesler, he wrote a script which, in conjunction with the find utility, I could find files with the modification time of longer than 45 days, and they are encoded in FLAC. FLAC is a lossless compression for audio, and there's a VLFRX Tools utility that will compress the PCM channels into FLAC while preserving their timestamps. So for a 1 hour chunk of spectrum data is normally 1.3 gigabytes. It compresses down to around 300 megabytes, which is pretty good. Then it archives to a much larger hard drive for archival and storage. So what I have it doing is every time that the main hard drive or the data store is about to reach its limit, it looks for files that are older than 45 days old. It encodes them and sends them to the much larger 14 terabyte drive. So I implemented that, and it seems to be working rather nicely. So this way, all that data could be saved on a drive, and as the drive fills up, another drive could be added. So this is a nice way to keep the data for the long term. So I'm really happy that everything works. One last thing, from November 1st to the 3rd, NAA, instead of being negative around negative 40 some microhertz off from 24 kilohertz, it was actually on 24 kilohertz, and I recorded phase plots that look very much like other transmitters that are dead on the frequency. So yeah, I thought that was an interesting anomaly that for 3 days NAA was finally on right on the frequency. That's all I have. Back to the net.
Very good. Next on the list is Michael, AC0G. And Don, for your information, Michael has an article coming out in the next Tapper PSR on how to make a grape without a grape board. So go ahead, Michael.
Thanks, Dave. Hello, everybody. Yeah, I got that off before the end of the month. And so not sure when it's going to come out, but I'm hopeful it'll provide a walkthrough for individuals who can install Mr. Gibbons' Raspberry Pi image and build cubic SDR to control a GPSDO discipline radio. I got so that's pending. I also managed to get some discipline set up for an open HPSDR radio. So built an Excalibur board, and that works good. I just have to move the modified FL Digi that Mr. Gibbons wrote over to Ubuntu so that it will produce the same kind of files that it does natively on the Raspberry Pi image that he created. And that way I can have 3 or 4 contributors to the repository on different frequencies for monitoring WWV. Unfortunately, at the absolute present moment, my Radio Shack is in disarray because we are renovating the garage where it resides. And so I got everything all in boxes and stuff ready to move over to the new section. Back to Ned.
Fine business. And next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Well, thank you, Dave. You can hear me okay?
Yes.
Yep, not a lot going on this week. Had to change a few emails with Bill, getting his magnetometer up and going. Hopefully that's going okay, Bill. Other than that, that is about it. Back to you, Dave.
Okay. And the last on the list is Tom in 5EG. Go ahead, Tom.
Okay, Dave. Good evening, everyone. This is week 7 where Starlink is still dead and no internet at home, so I'm at the neighbors. We've replaced every part in the system 3 times except the dish, which Starlink doesn't seem to want to replace. Suspicion seems to be going that direction. This week, I restructured all the C code to layer the device drivers and the peripheral handlers into 2 layers. It's very clean now. The LHDE protocol selects the handler by module number and interface number. And that table now provides a string to the device driver, and it provides a pointer to a function. And that makes, in the future, adding modules, meaning that you don't really have to rewrite code. You can just add lines to the table to add additional peripherals. Very clean. And I wrote a parser for the LHDE commands. It fills in a structure. So you pass a pointer to a structure and a pointer to a handler to the module, and that all seems to work great. I've got the control module stuff completed now, and it works on the receiver, so you can toggle the relays and LEDs. You can read the status, and it all talks to the LHDE protocol. That's all working great. I got the ident ROM code working this morning, so you can read the unique 72-bit serial number from the ident ROM. I've got the Verilog coded in for that for the receiver. I still have to go add that code to for the clock module, but it's basically just a table entry now to wire up the Verilog for the clock module. I've started working on the handler for the Silicon Lab synthesizer on the clock module, and John Ackerman gave me some hints. We've resolved that the A2 address on the I2C for the synthesizer chip is pulled up, and that the I2C select is pulled up internal to the chip. The A0 slave address bit is neither pulled up nor pulled down according to the documentation and is unconnected on the chip. And so I've got the handler written so that it will try both addresses with A0 being 0 and A0 being 1. We'll see how that turns out. The Altera driver, if you pass it a non-existent slave address and try to do a read, hangs the entire FPGA system and crashes it. And so some debug work required there to see if we can figure out how to determine if the input floats to a 0 or it floats to a 1. I'm not sure yet. It might, we'll test it out and see which way it goes. Getting to that pin on the chip on the receive on the clock module is what their ball grid, not quite ball grid, but pins on the edge of the device on 25 mil or 20 mil spacing. And the finest scope probe I could find covers about 5 of the pins on the part. So trying to rework that part, if it needs rework, is going to be a challenge. So all in all, a productive week. A bunch of drivers are up and running on the board. We can talk to at least 2 of the peripherals on the receiver board. After I get the clock module up and running where it can be programmed and send out the right frequencies, then I'll start working on the SBI interface handler code for the ADC on the receiver. So that's it for the week. Oh, the Starlink is flaky enough that I can get 17 meg upload and kilobits per second download for a good 30-second period, and then it craps out again. So that's been the week.
Well, sounds very productive, Tom. And we do have Bob Scupa. I'm mispronouncing it. Scorpion. Well, Bob, go ahead and make a comment if you want. Well, where'd he go? He was there, but he disappeared.
I think you made him mad.
Oh, yeah, I can't pronounce his name. I'm sorry. But maybe he didn't want to be seen. Or his
Karupa was probably the correct pronunciation.
okay. Well, given that, I think we're open for general discussion.
Yeah, so Tom, if we can't get that to work with that pin that float, then I've got some clock modules here that I will take down and have the wire put on by the CM. I can't do it either. It's too fine. But if we can see if we can get the CM to do that, then I'll just swap you out clock module with one with a wire on it.
Okay. You know, I had a couple of emails with John Ackerman, and he said on the test board, they let that pin float as well, but they bring it out to a pin field so you can strap it one way or the other.
Yeah.
And so best case is the documentation for the part is wrong, and there's some kind of internal pull-up on the pin. That would be my hope. So I'll test it both ways and see if it's semi-reliable one way or the other.
Can you get your finger on the pin, or is it underneath the part?
No, you can get to the pin. It's on the edge of the part.
It's on the corner, right?
I don't remember that. There's 1 or 2 that are in the middle and a couple that are near the corner. And I don't remember which one that address line was on. I was worried about all 3, but the documentation does say that 2 of them have internal pull-ups.
2 of them are pulled up, right, which is why you left them float. But the third one, if you can get your finger on it, this is my test for floating CMOS, is to try reading it one way and then put your finger on it. And generally it floats around, flops around, and then if it really is not pulled up, then it'll cause trouble.
Yeah.
Yeah, my finger's about the width of 20 of those pins.
So you got to push down real
Yeah.
hard. So
Charge up a cat. Charge up a cat and wave that at it.
Your finger's
I-
probably 10 or 15 megohms. So
Yeah, I had a design about 20 years ago where I had, it was a wire wrap board and I forgot to wire wrap up one CMOS input. And all I had to do was bring my hand within about 6 inches of the board and it would start working. And if I moved my hand further than 6 inches away, it would quit working. And so there was just enough capacity between a hand 6 inches away to make it go to one logic level as opposed to the other logic level.
I built
Yeah,
a
especially in the winter, when you get yourself charged up, you can just wave your hand at it and it'll change the state.
I built a
Yeah, I
WD4
usually
VP.
find that coffee in the morning is better for charging up.
I built an AccuKeyer, a CMOS AccuKeyer years and years ago, and the article in, or I guess the PC board that Far Circuit supplied had a missing trace on it, and I debugged it by putting my finger on the chip and moving it around. Of course, it was a dip, so it was like pretty easy to figure out which pin it was that was floating.
Yeah,
It would work fine until you put your finger next to the chip, and then it would go wacky. So
yeah. It's interesting. All these I2C devices are all radically different from each other in how you access 1,000 registers from a 7-bit address. And so,
yeah.
That's when I decided to layer the architecture into the low-level driver, which is I2C, and which talks I2C and doesn't know anything about the device, and a function pointer to a handler, which knows all the specifics about the device, and then calls via the /dev/device name string into the driver. And that seems to work really well.
Sounds like good progress.
Yes.
Is
Yeah,
that
so
a
anyway-
leadless chip carrier that chips in?
No, the chip it's got leads underneath, but at the edge of the part.
Right,
on
that's
the
called
far
a
outside
leadless
corner.
chip carrier, where it's
And then
underneath.
Yeah, and then it has a ground pad in the center, which is soldered down to the board.
Right.
And so it's, I don't know what the name of that thing is, but you can get to the pins, and you can actually see them given sufficient magnification, you can see the pins.
Right. Scotty, does that actually have a pad that's accessible outside the periphery of the chip?
No, because it's not connected to anything. So it's got just a pad that the pin sits on, and that's all.
Yeah.
So
I
if we
like to have those so that the pad comes out enough so you could actually put an iron or a
you'd like to
wire
do
on
that,
it.
but when you see the size of the clock module, you see that we don't have any room to do anything. So it
Right.
would. It's just unfortunate that I didn't read all of the notes and find that one because the other two were floating fine. And normally I don't like to leave pins floating. I think relying on internal pull-ups is not a generally good practice. But,
Yeah, but
in the case where I don't have any space.
Yeah.
But do you think someone with small fingers will be able to wire that?
It's possible. Yeah, I have to look at it and see. But
34 gauge wire.
you have to use very narrow wire because the wire is wider than the pin spacing. So,
right.
Yeah.
But they can do pretty big miracles over at the CM. So we'll see.
Right.
What
Yeah.
they can do.
So there's I'm hoping a 50-50 chance that the data sheet is wrong and that it actually does have some kind of pull-up on it.
It would make more sense to have a pull-up. That's ridiculous to have it float.
Yeah,
Well-
when John programmed the part on the eval board, he didn't have any issues. I don't think he strapped it, and I think he left it unconnected.
And did that just come out that pin high?
I don't know because he used Clock Builder to program the part, and it knows what addresses to go look for. So I'll find it. The only problem is debugging is hard because as soon as you try to do a read of a non-existent address, the whole environment comes crashing down.
Yeah, there's got to be a way to fix that because that's especially if it's flaky and sometimes it's high and sometimes it's low, but you read both of them. So you read one, you get no response, you throw that away and you read the other one. And I know we had an issue in another board where I didn't do the hardware on that one, but they left the program select. It was a max 10. They left the program select pin float. and program select pin decides which of the two images you're going to load, depending on whether it's high or low. And they let it float on their board and it's not pulled up. So what they did is they just tried it. And if you got the wrong image, they forced the other one. So, and so, I mean, it was a hokey way to fix it, but it worked. So,
Yeah,
and you know, they'll strap it the right way on the extra vision.
yeah, we'll see. I've gotten all the code written to read out the part number from the synthesizer module. And so if that works, I'll know. One of the things I can do is if I can try to write to the part, and if it knacks the right on the Altera drivers does not hang on the non-existent device, while the read does.
So why does the read hang? Is it not have a timeout or anything?
I looked into it. It makes 10,000 attempts to read the part on a read that knacks the read. So I ended up.
And what does it do after 10,000?
It returns some kind of an error code, but I've ended up having to read the Altera C drivers for every single part that I've touched so far, because they all do kind of interesting non-documented things.
Yeah.
At any rate, so the progress has been reasonably good. The image boots up stably. It gets a DHCP address. It comes up and runs pretty much every time. And I've written a command line interface in Python to the DELH protocol. And that allows me to manually go in and type all of these commands, read the ACKs, read the NACKs, read the read responses. And so that all of that part is coming up pretty well.
Sounds good.
Yeah.
The Starlink was good enough this morning. I actually pushed the latest image to GitHub. So that image, meaning if you know all the magic and you have all the utilities and you know all the magic values, you could actually try it out, but there's no documentation.
So is your neighbor getting tired of you using his internet?
Not so much. I find bringing a bottle of wine helps.
Yeah. It's like the tower party we had last weekend and with the pizza party afterwards.
Yeah.
Always helps.
Yeah. I don't know how much longer I'm going to have to wait before I just throw in the towel and get some other kind of internet service.
Do you have any choices?
One other choice, which is the cable TV provider.
So is that Cox or is that someone else?
No, it is, they call it Spectrum on the West Coast, and I don't know which provider provides that service.
Can you get decent speeds where you're at?
I think so. The house, there's wiring buried under the yard from their box to the house, but it's never been tested.
Doesn't sound good.
Yeah, so, you know, if you find a ditch witch in my yard next week, you might know what's going on.
How long have you had this Starlink, Tom?
I got it in June. It worked perfect for 4 months, and then one day it failed.
Huh.
And Starlink just keeps replacing the same units over and over again.
Huh.
To the point where there's only one particular piece of equipment, that's the outside dish, that hasn't been touched, and they seem unwilling to replace that unit.
Well, that's not good.
Yeah,
I'm using Starlink right now, and I really hope it doesn't break.
Yeah, for me, it was absolutely perfect for 4 months. And then the day after DCC, I got home and it was deader than a doornail.
Ah, that is so painful.
So
Yeah.
I've been out about 2 months.
Have you
out of
shooed the cats off of the dish?
Yeah, right. Yeah. I turned on the high voltage electrification field around it, but
Yeah.
it didn't clear any problems. So I did find a YouTube video where apparently other folks have had the same problem I'm having. And
What
so
was
I'm
the
guessing
solution?
a new dish.
Which they won't do. Nice.
Well, yeah, whoever did it, they got them to replace his dish. I've so far not been sufficiently charming to get that
Maybe
to
you
happen.
could accidentally shoot your shotgun through it or something. And
So at any rate, we'll find something. But in the meantime, the rest of the project seems to be, going on progress. The I2C devices are very time consuming to debug.
yeah, and all you have to do is violate one setup or hold time and it doesn't work.
Yeah, most of it is, you've got to fire up you got to download the FPGA, fire up the software stack, fire up the command line interface, get it all up and working, get the addresses, and then hope the debugger doesn't crash. I found that you cannot put a task to sleep and have it restarted by the RTOS while using the debugger. If you try to sleep a task while the debugger is running, it crashes the stack. And so you kind of have to do this sort of, you can debug, but you can't do OS task changes while debugging.
Yeah. Like trying to debug interrupt code, right?
Yeah, so as long as I don't do a task switch, I can debug and look at status codes returned by calls and things like that. And that works okay. So, so far I'm saying I'm happy with the progress. Things are stable and it comes up and runs once I figured out how the I2C device does its different thing.
Sounds good.
So Tom, you don't have a sharp enough probe to probe these pins on that chip at all? No, I have something about the diameter of a sewing needle, which under the microscope looks like trying to apply a snow shovel to a dip.
What chip are you talking about? What is it?
It's a Silicon Labs 5345.
Okay. The other thing I've done to try to force a pull up is use some like the foam that you find chips plugged into. That's a
Yeah.
high resistive material, so you can use it sometime. I was thinking if you could probe that pin, you could turn the power off and probe to VCC and ground and find out if you got any resistance there, but maybe isolated by a pin driver on the IO of the IC, and the pull-up may be internal to the chip.
Yeah, that's a good point. If I were to use foam and just lay it across about 6 or 7 pins and tie the foam to VCC, the ones with internal pull-ups or pull-downs on the chip would probably have a lot less resistance and stay at their logic level. And that foam might put just enough leakage into the pin to pull it up. So that's a good thought.
You basically need the old technology of a cat whisker.
Yeah. This would have to be a really skinny cat.
Well, that was the purpose of your finger, a 15 mega ohm resistance to all the other pins on either
Yeah, a
side.
little tiny wire pointing, on a crystal galena.
Okay.
You could you could get it off your dish after you apply the voltage.
Yeah, there you go. Yeah, just apply a charged human hand 6 inches away, and maybe it'll come up. So I'll try it with all the various levels and see which way it seems to want to work. Like I said, Ackerman sent me the schematic of the eval board, and they have it no connect
and to a pin field. And so I'm really hoping it's just a documentation problem.
Yeah, that could be.
And they treat it the same, both both address bits the same, right?
You would have thought so, but the data sheet clearly says that one of them is pulled up. One of them has no pull up or pull down, and then the select pin has a pull up. So it does specifically say that in the documentation. So after that, I will code the handler for the U-Blocks module. And I haven't looked into that yet to see what's needed. There's one other part I've got to code a handler for, so it'll be a couple of weeks to get all that code written and debugged.
Yeah, it says specifically it does not have a pull up or pull down.
Yeah, exactly. That's the worst kind of documentation.
Yeah.
Going through the Altera, I was trying to debug why the read was crashing. And the documentation says that the size parameter controls the width of what's written to the I2C device. This is in the read routine. And so that's, of course, when you go into the source code and you start reading the source code.
The good news is the A1 pin is a corner pin.
Oh, it is. Okay.
It is. The A0 is not, but the A1 is.
I think it's is it the A0 that floats or the A1 that floats?
The A1.
Ah, okay. So I'll go back and fix my code and try the other addresses.
Yeah.
If it's a corner pin, we got at least a small chance of reworking it.
You have a chance, right?
Right.
See, it's pin 17 and it's 16 pins on the side.
Okay.
So hold on, I'm looking.
Pin 1 is a corner.
Pin 16 is a corner and 17 is a corner and 1 is a corner. Yes.
Yep.
All right. So that would there's a chance with that. There's a chance.
Okay, 1 second here and I'll put it up here.
But I actually am serious that, what we call a cat whisker, take like 34 gauge wire and ground it or connect it to something and then touch it to what you can get to of the pin.
Yeah.
Okay, let's see. That should be there.
I'm curious. So the Tangerine, does it run on its own, or does it need like a Pi or computer in general paired with it to run?
That's a Bill question.
Needs some kind of host computer, whether it's a Pi or something else.
Yeah, but I've got software that will run her on a Pi. But that software could also be implemented on some other type of computer. Doesn't have to be a Pi.
Okay, so this is the synthesizer we're talking about, right? Which is
that's needed. That's needed to generate the 122.88 clock to the receiver.
Well, I see it as U12. Why is? Hold on a second.
Is this the 5345 chip you're talking about?
12, yeah.
Yeah.
It's that pin.
Yeah.
Right
That's
there.
the jitter attenuator.
Yeah, it's a jitter attenuator and synthesizer, and it takes the output of the U-Blocks GPS module and synthesizes 122.88 and some other things that are used by the receiver.
Oh, there's the pin descriptions.
So 17 figures. It's between the clock and the data pins. Boo hiss.
So the A1 is pin 17, A0 is pin 19.
Right, so let me share my screen here. If I can do that. So can you see my cursor? It's this pin
No.
right here. You can't see my,
No.
my little
Oh, I
hand.
see
Yeah, I
it.
see.
Yes, yes. It's just small.
So if it's the big chip right in the center, and pin 1 is in the upper right. So pin 16 is the upper left, and pin 17 is the first one, the top pin on the left side of the chip. And you see there's a trace kind of curlicuing around it.
Right.
And so the pin 16 and pin 18 are the clock and data lines for the I2C. So, I mean, ideally what we would like to have is if we could just solder short it to an adjacent pin, but can't do that because those are both wiggling pins.
Right.
But I think that is doable with a wire
Okay.
by the CM. Depends on what, I mean, I gotta look to see what is above it. Okay, let's go over here. This is this pin right here. And it is this resistor right here. I'm thinking if one side is, if it's a pull-up resistor, then we could run the wire to one side of that resistor. We just tie it to VCC or ground and just tie it off to something that's static.
Right, right. That's all we need.
And it's C16, R16. Okay, so just a second. I gotta find the assembly drawing, the real assembly drawing, the fab drawing. Wait a minute.
Just had your cursor on it.
Yeah, but this one right here, that's the one I
No,
was.
below that. No, there's one that's titled Fab Drawing. Is that what you're looking for? That
I
one?
don't know. I don't know if that's the right one or not. No, that's not going to
No,
do it. That's just the drill and the layer.
that's the drill.
But they have the assembly drawing should have. Oh, I know what I want to do. I got to go up here and to this. Now, if I can get the silk screen, this may be the one that would work. Yeah, okay, so it would be, yeah, which resistor? Okay, it would be this resistor right here, I think. Any one of these three would actually work. So R11 and R15 maybe, and R13. R15 is a pull-up. Okay, that's on 3.3 volts. So that is the middle resistor, I think, here. So that probably, depending on where it is, especially if it's on the bottom, if ECC is on the bottom. Yeah, R15 is right here. Yeah, I was hoping for these guys over here, and I don't know what that is. That's that's U9, that part. That's an oscillator.
Scotty, I'm reading the pin descriptions. A0, which is pin 19, does have a resistor on it.
It does.
Pin 17, A1, does not.
Does not, correct, which 17 is the upper pin on the left side.
Right.
So you could actually bridge it to the third pin because that's got an internal pull-up, and hoping that the internal pull-up would be enough to pull an external pin up too, but that may or may not work.
Yeah, the interesting thing is it says in I2C mode, it's A1 address, and it does not have an internal pull-up or pull-down. Then in 4-wire SPI mode, it's an output, leave disconnected with unused.
Right.
But I'll bet most people read that and say,
and that's what I
leave it
did.
Disconnected.
Read it.
But as in I2C, you want to assert it.
Leave it disconnected with unused. It's unused, so it's
But that it says that, but it would be in connection with SPI mode, not I2C mode.
I'm looking for.
That's a bad design.
U9 right here.
And bad documentation.
Pin 6 of U9. Pin 3 and 6 are 1, 2, 3. Okay, so you see pin 3 where my cursor is right here?
Yeah.
That's 3.3 volts or ground, one of the two. So you can you can just connect that pin and that pin together, the world's shortest wire.
Mhm. With the world's highest magnification optics.
That's their problem, and they have magnifiers, and they have steady hands, and they have small wire.
Yeah.
They did the rework on the magnetometer, which wasn't as, I don't know, I would say it was probably worse than this because they had to take a part and swap pins.
Uh-huh.
So if you look down here at U14, imagine having to swap like pins 2 and 3.
Yeah.
You have to lift pins up and then hook a wire to 2 and hook it to the pin on 3 and 3 to 2 like that because I got 2 pins reversed.
Mhm.
And I kind of butchered up one board and I got it to work, but it didn't look very nice. So I took it down to them, and after they stopped laughing at my rework, they reworked it themselves, and it looked much nicer. So
all right. So anyway,
Yep.
yeah, that
Good.
we got options there. I'll try it and see which way it goes, and
yeah,
hope
so
that
I don't think the rework is that hard if you want to
or something.
see pin 3 of U9. This is U9 right here. Pin 3 is ground. So we would pull it down. So it'd be a low.
That'd be fine. That part is interesting. It has both 1.8 and 3.3 volts on it, and
Yeah.
it powers up into I squared C mode, 1.8 volt I squared C. That's how that chip powers up. But
Really?
you can, yes, but you can program it to go into 3.3 volt I squared C mode by setting a bit. And apparently just that instruction will work correctly when you apply 3.3 volt I squared C, and it still hasn't yet been programmed out of the 1.8 volt mode.
Oh, that's bizarre.
Yeah, so all of those chips have things like that in the programming.
Because you think as an input, a 1.8 volt input will work at 3.3 volts.
Yeah,
If it's 3.3 volt tolerant.
Yes,
and
it is 3.3.
Yeah, and if it's open drain output and it's pulled up to 3.3, it'll work as an output too.
Yeah.
So what do they change when you go from 1.8 to 3.3?
I'm guessing the logic 0, logic 1 threshold voltage gets modified.
But even so, so at 1.8, the VIH would be what, 1.5? But you're pulling it up to 3.3, so that's going to certainly work.
Yeah, but it's probably the VO. It's probably the low voltage where they move the threshold up.
But the low voltage should be the same because you're pulling it to ground and you're working against the 4.7 K. I mean, that's not even a milliamp of current.
Yeah, well, you can read the data sheet. That's the first thing you got to do when you power up the device.
That's strange. Well, if I could read the data sheet, we wouldn't be having this problem. So,
yeah.
But you know, we're expecting to have some problems with prototypes. That's why they're prototypes.
That's why they're prototypes.
Something that we can fix easily.
Yeah. So the ident prom is interesting. It powers up in a sleep mode, and you have to wake it up with a magic sequence before it will come alive. And the magic sequence only works at 100 kilobit I squared C. It doesn't work at 400 kilobit I squared C. So all of these parts, that's why these handlers all have to be completely isolated, because all these parts have things like this.
Yeah.
Yeah, Scotty, in reading this, and I've run into this before because, I've worked with lots of chips that have both SPI and I squared C on it. The notes that they're giving there for pull-ups and such are actually for the SPI setting for the interface. They're assuming that if you're doing I squared C, you're going to be asserting the address pins.
Well, the address pins,
because otherwise you don't know what address the chip's been set to.
Yeah, the intention of the address pins is so that you can put 4 synthesizers
right But you
Two
should at
items.
least ground those if you're not going to use the addressing.
Well, if it says
So
it's
it's
got a
at
pull-up
0,
on it, if it's got a
Yeah.
pull-up on it, then you don't need to ground it.
Yeah, well, but A0 has a pull up, so now it's at a 1, not at 0.
Yeah.
Right.
So
Um,
my hope
You
is
can do
that
that, but
in the
if we're-
in the I2C mode, my hope is that the turned off disconnected SPI pin has got enough leakage one way or the other that it makes up its mind and stays there.
it doesn't. It will float back and forth. I've had that happen.
Which one are you
Yes.
talking about? The select pin? I2C
No.
select?
The one that's not asserted,
Yeah, the address pin.
Oh, the
right?
address
That
pin,
address,
right.
it'll just float to whatever it wants to. And the problem also is they float in the middle and draw a lot of current through it.
Yeah, so eventually it's got to be fixed, but I'm
Yeah.
just hopeful it'll make up its mind long enough we can debug.
But I guess what I'm trying to say is note for the future, if you're running in I2C mode, always assert the address pins one way or another. Don't let them float.
But like I said, when I read it and I see that there's a pull-up on it, I assume that they're not.
No, I
working.
know. I hear you.
And
Do the same, but in this case,
it's funny
poorly
because
written documentation, but
I used to fight people who would leave TTL inputs open, saying, "Oh, well, they'll float high because they're, the logic."
Mhm.
And I go, "No, that's bad design practice. You should, if you want it high, you should make it high."
right.
And then they also have well, you shouldn't tie inputs to ground. You should pull them down. And I'm going like, bull.
Tying it to ground is fine.
Time to ground. That's perfectly okay. And you can let them float, but it's not recommended. And I tell you what, we had just a big fracas at Motorola when I was there because they had designed a whole bunch of boards with bipolar PALs. You know what a PAL is, right? Programmable array logic. It was a fuse link type programmable part. Well, then Lattice came in with their generic array logic or GALs. The GALs were all CMOS.
Right.
And they mass replaced all of the PALs in the board on their production board with GALs because Lattice said they are drop-in replacements.
Right.
And you know what? They stuck to that story worse than a politician who got caught lying. They told Motorola that those things were pin compatible and drop-in replacements, and they were sticking to it. Well, it's not true if you float the pins. It works on the bipolar part, but it doesn't work on a CMOS part. So on the parts that were bidirectional, we could reprogram the GAL to make it an output, and it would fix the problem for floating pins. But if we didn't, and some pins were input only, so you could not do that. And those pins would do exactly what you described. They would float into the transition region, and they would draw a lot of current, and then they would cause the PAL to malfunction.
Correct.
We had a bus controller that at elevated temperature about once a day would be happy to grant the bus to 2 requesters at the same time. The encoder just didn't work right because and it was a totally irrelevant input. When we put a wire on that input to ground it, the problem went away.
Right. Yeah, the thing is that with TTL, even if you read the documentation very carefully, you're not supposed to tie a pin directly to the +5.
Yeah,
it can actually break down.
But you can do it to ground.
You can do it to ground, yes, but to +5, they actually said put a 1K resistor.
Yeah.
To
and I don't know if
assert
you
it
knew
high.
this too. If you overdrive the base of a transistor, you can actually end up degrading the base emitter junction and reducing the HFE of the transistor until it doesn't function right anymore.
Yeah.
It'll sort of function, but the gain will be so low it won't switch. It's as a switcher, it won't work right.
Yeah, I think that once it went to LS, you could tie them straight, but for
The regular TTL. Of course, this is all LS and S logic. So
right.
But still.
Yeah, and in fact, oh, by the way, I didn't realize until I was rereading stuff that the Max 10 is a PLD.
Yeah.
It's a PAL.
Yeah.
It's a direct lineage from the Max
Max 5
PALs, their original.
When it first came
CPLDs.
out, it was listed as a CPLD, but it was
the architecture is more like a FPGA.
Well,
than a-
what it is it's a FPGA with internal programming memory, so it looks like a CPLD. You don't have to have an external.
And actually, ironically, that's its best feature is that internal ROM.
Right.
Because it cuts the pin count down, and especially since it's big enough to put 2 images in, you can have a hard, well, not hard coded, but a static bootloader that stays there all the time, and then you program. So if you accidentally load something bogus, you don't brick your radio. Anyway, such fun philosophical discussions. It's moot anyway, since you
Well,
can't buy any. So
well, it's also, no matter how much things change, they stay the same.
that's
We've been
right.
having these problems since day one with this logic stuff.
Yeah.
Give me analog.
Give me an HQ 129. Never mind this SDR stuff. And actually, I bought an HQ 140 at the last swap meet. Really nice, clean looking radio. I don't know if you knew this, but the HQ 140 is the only radio in the Hammerlin line that had brown knobs.
Really?
I looked at it and I go, those aren't stock. You did something to this radio. You changed the knobs. No, I go back to the historian book, and they list them as chocolate brown.
You only did it on one radio, huh? Went back to black.
Yep. And you remember when M&Ms had 2 colors of brown? That's been a long time ago. They had the dark brown ones, and then they had the chocolate brown colored ones. And the knobs are that color. So I found a YouTube video of a guy who restored one. And sure enough, they were brown. So kind of weird.
Some new guy.
Some new guy, yeah. It's only made in what, 1955? It was a successor to the HQ 129, which stopped production in 53.
Oh, okay. That's the same vintage as the shoot, the portable shortwave radio. The
like the Zenith, you mean?
Yeah, the Zenith.
Transoceanic?
Yeah, I have a Zenith Transoceanic that was
built in the 50s.
It was built the same time I was.
What's the status on the magnetometer boards? Are they still in test, or I might have missed that last week?
No, the boards are all done. Production run is all done, and they're in at the Tapper office, and they're all tested and packaged and ready to go. But we're still waiting for me to get off my butt and write the manual, and then to make sure we have the right we have the repository set up, right, Nathaniel? We're still,
yeah, that's right.
so we still can't
repository to take data in.
to take data, right?
Yeah.
I feel like we're in this stage where we're very close on a lot of things, but we're still very far away. I don't know.
Yeah. Well, I'm getting to the end of this project that's sucking up all my time, so I'm hoping I'm going to be able to, it won't take very long to write the manual, but as Bill, I think Bill left, but as Bill knows, there's a few key points that you have to follow. Otherwise you could have trouble, like which direction to put the magnetometer board on.
Yeah.
Right.
It's not, I mean, it's obvious to us because we've done it, but it's not obvious to a new person who has never seen the board before.
So,
We have to tell them.
So what do you need in terms of help in writing the manual?
Oh, nothing, just sitting down and doing it. I got all the pictures. I took pictures.
Okay.
I'm gonna have just put, I want to put pictures of the board with arrows and all that. And I was hoping Jules would be here tonight because he sent me a really great set of pictures on how he mounted the magnetometer in the pipe. And what he did was he took a small piece of tubing and mounted the magnetometer in that, and then mounted that with a coupler onto the however long piece of pipe you want, however deep you want it. Right. So in other words, you can RTV the little short piece on into the coupler, but then you can glue the pipe on, you can glue the coupler, I guess you can glue the coupler with PVC cement on the top side, and then the bottom side, you want to be able to pull it out so you can service the magnetometer. You got to be able to get to the board. But I think that's not necessary because you can pull, if you just leave the end cap not glued, you can pull the end cap off and slide the board out. And he was using little tabs to hold the board in place. And I think because he was having trouble with the pipe, the foam pipe cover, he said he tore the one of the ground leads off, the jumpers off because it was an SMT jumper. And yeah, you got to be a little careful with that. But the reason it's on there as an SMT jumper is because it's installed by the factory, and factory will install SMT parts for almost nothing, but they cost big bucks to put a through hole part on. So we could leave that off and let the user put it on. That would be an alternative, and then it would be more robust. But I think with a little care, what I do is I take I don't know if you've seen the foam tubes that you buy they're used for insulating pipes, and you can buy them in half, 3/4, 1, all those different sizes.
Right.
Well, it
the
turns
hot
out that,
winders. Mhm.
yeah, so it turns out that I believe the 1/2 inch size, the OD is exactly the same size as the ID of the 1.5 inch PVC. So it fits snugly in there. So what you do is you take that and you cut it in half horizontally. So now you have an arc, right? And then you put that on the bottom of the board and you use it to push the board up against the curvature of the PVC pipe. So now you've got a flat board here and a curvature, and it just sits perfectly vertical because the two parallel edges of the board are touching the arc of the pipe on the inside. And then below it, you have the foam pushing up on it. And you can slide it right into the pipe and it stays perfectly vertical. And you can even, it's not really tight, so you can actually rotate it to align with the marks that Jules puts on the pipe, because he marks it to show which direction it points. So once you, and he makes marks on the top and bottom. So now when you bury it, you can see by the marks which direction the magnetometer is pointing, and you align it to face north. So pretty slick way to do it, but I thought he was going to use the foam and not glue in little tabs. It seems like the foam is much easier. So I have to get with him and find out why he did it the other way.
Well, I'm ready
Yeah.
for one. I'll bury it and start trying to collect data as soon as you got them.
Okay, well,
Yeah. So I'm asking Sally because I have the magnetometer kit, and I of course know what I'm doing and I can assemble it, but I was wondering what kind of feedback you wanted into, I presume, as to what could go wrong.
yeah. And I think you told me that you had a problem with the jumper. Was it you that told me that, or Jules?
No,
told me
not
that? Okay. He said that he had interference problem with something, and it tore the ground, the shield connector, shield jumper off the board. It was an SMT part. You know, they come down, the vertical pins come down, and one goes that way and one goes that way. So it
Yeah, I know.
it's not very robust on the board. So through hole one would be better, but then we'd have to
Relies
have the users.
relies on the glue of the that they use for copper onto the.
Right. It tears the
substrate.
copper pads off. Right.
It does, yeah.
Yeah. So one solution is you can make the pads bigger, but I think, you know, if you're going to have to solder a 40-pin connector anyway, you can solder a 2-pin header. So just let the user do it.
Sure.
Just supply the pins and let the. It's a kit after all, so you want to have fun with your kit. So a couple more solder joints should be no problem.
How deep are you suggesting to bury these things?
I think 3 feet is what Jules is suggesting. Because Hillman's still here, right? Is 3 feet enough? Guess it depends on your climate, maybe. It's mostly to stabilize the temperature.
Right.
So
Yeah, I think 3 feet's recommended, but yeah, it is for temperature stabilization.
So if you're way up north, you might be more critical of the 3 feet. And I mean, maybe out here, if you don't go 3 feet down, it gets warm because it's the desert. So the 3 feet.
Yeah, around here, you'd bury pipe 6 feet down.
Well, you don't have permafrost, do you? It's just
Not
doesn't-
anymore.
So do you get at 3 feet, do you get a temperature differential between summer and winter?
Oh, yeah.
How,
No,
how,
yeah, around here you have to bury your pipes at 6 feet, otherwise they can freeze.
really? Okay.
Yep. And we've had that if you don't get a snow cover. That's assuming a certain amount of snow cover. But it also is assuming 30 below weather, which we don't get anymore.
Yeah. Well, and then they were talking about, putting some kind of crystal oven type of thing. You wouldn't need very
Right.
much power because it's well
No,
insulated.
I've
So,
actually designed ovens for various things.
yeah. We probably have enough power to do that if we wanted to do that, but that's at some point you have to shoot the engineer and ship the product, so if you need 6 feet down, then go 6 feet down. Then you can use it
Well,
with
you don't shoot the engineer, you ship the engineer with the product.
with everyone.
Yep. Oh, we've had many a board like that where, you have to lay on a finger to make it work and say, well, okay,
Here you go.
ship it with the engineer.
Yeah. That reminds me of a friend of mine that works in the Northeast. He's in Massachusetts, and he's retired now, but he worked for a company that made power meters, watt hour meters for houses. They had a Wi-Fi, or not Wi-Fi, but it was a wireless reader. So what they could do is they could drive the truck down the block, and they could read the meters directly with the radio equipment in their truck. Well, they had this area in Florida where this group of meters couldn't be read. They just didn't respond. And so my buddy, who is a ham, he looks at the circuitry and he says, well, you didn't put any filtering or front end at all on the radio. And he looked at the location of the meters that couldn't be read, and they were right next to a broadcast station. So they sent the engineer down to fix it, right? And so my buddy and his assistant engineer said, bring your swim trunks, we're going to the beach, because I know exactly what's wrong. It'll be fixed in 15 minutes, and then we're going to spend the rest of our day at the beach. And the guy's going like, well, his assistant's going like, well, how do you know? You don't know what's wrong. And he says, oh yeah, I do. So they got down there, and sure enough, it was just overload on the front end of the receivers, and he just put the filter on it. Then they went to the beach.
And I will tell a story of where laying on the hands broke things. Where we were building, doing memory boards for our computer and internal house computer, and using the NMOS static RAMs.
Yeah.
And plastic parts worked fine, but we had some ceramic parts, and we found that if you laid your hands on them, that the thing would crash.
On the plastic parts?
No, the ceramic.
Oh, okay. And they had a metal
would
lid,
crash,
right?
but the plastic parts were okay.
And the ceramic.
Well, what
had
it
metal.
was is there was this little, you could see a little gold trace coming out the end of it. That was the charge pump. That
And
was
it
a lead to
the
the
die,
charge
right?
pump, and if you touch that, you crash the charge pump, and the
Oh,
RAM would die.
God. Oh. We had exactly the opposite problem. My first job, it was an 8080. It tells you how long ago that was.
This is the same vintage.
Yeah. So
Yeah.
they were buying ceramic parts, ceramic 8080s from Signetics. Well, National came out with a plastic packaged 8080. So they thought, well, they cost half as much. So let's save a couple bucks and let's buy the cheap plastic ones. They put the plastic ones in, they didn't work. So my job was to find out why they didn't work and to figure out to make whatever change needed so they could buy the cheaper parts. Well, it turns out that they were violating the setup or hold time, depending. This is horrible. On the memory board, they had a one shot that had a pot. And in manufacturing, they actually put a scope on it and then to set it for a particular setting so that the read would occur to meet both the setup and the hold time of the part. Well, it turns out if you analyze it and look at the data sheet, the circuit would not meet both the setup and hold time. It just turns out that the plastic part, the ceramic parts exceeded the setup time so that they could set it in a range where it would work, but the plastic parts did not.
Mhm.
So they overlapped like this, and there was no way that you could actually set it so that it would work. So the solution was by the ceramic parts.
Right.
And actually the solution was redesign the memory board, which is what my next project was. And I did that. I used 4K DRAMs to replace remember 2102s?
Oh yeah.
Wide, 4/10 wide packages. I got rid of them and I used 4116s, I think. And then I got the board almost up and running and they canceled the project. So I never got to see my board work. Gee whiz. But it was amazing that the difference. I mean, I don't know why the one die would work and one wouldn't. Maybe it was not a simple second source for the exact die.
Well, it may have been, well, of course, National would have been building it under license, but it may have been a different mask set.
Oh, okay. So it would be slightly different performance.
Right. Slightly different timing, just enough to make it.
Just enough to make it
fail.
not work. But I mean, even as a neophyte out of school, I looked at the design and I go, yuck, a one shot, really? That's how you tune your memory board? That's awful.
Yeah.
The board I designed, everything was all clocked, all synchronous. So there was no
Right.
adjustments.
Yeah, our system actually was asynchronous, but it had handshakes.
Okay.
So processor would go out, ask for data from a board, it would send it back and it would send a signal back with it to say that data's here.
Okay.
All stayed in sync.
Yeah, and these are probably 1 megahertz 8080s.
Right.
I don't know how fast yours ran, but probably that.
Well,
that
ours was a TTL reduced instruction set machine that we were building.
Oh, okay. So like the AMD 2900, that type?
Well, it used it was more basic than that. We were building it out of 181 ALUs and
Oh, okay.
our own static RAMs for registers and things like that.
All right.
The 7464 type RAMs.
Well, all right. Well,
But it was no slouch. We kept increasing its speed with going up to S and F logic and stuff. It was probably like an 8 megahertz 68,000
by the time you got
in terms of the performance we could get out of it.
not bad.
I have a question. I'm setting up a virtual box with Linux to mess around with that. And I was wondering if someone here knows, like, if there's a specific Linux that works the best for figuring it out, or if it's just whichever one you choose, doesn't really matter.
Oh, that's a good question.
If
What I
anyone
used to
knows
do is,
that.
where is the web page that has the list of how many times each distro is downloaded?
Well, I can give you some advice based on my experience. A part of it depends a lot on what you want to do. I use Ubuntu Linux all of the time. And the reason I do that is because it's very widely available and there's lots of help all over the internet on how to make it work. And so if I have a problem, I can Google it and I can generally find it. So it tends to be very friendly for people who are kind of desktop users and consumers. So I think it's fairly friendly for beginners. It's not going to one thing that Ubuntu doesn't have going for it is it's not necessarily considered as stable or as enterprise grade as something like Red Hat Enterprise Linux. But the problem with Red Hat Enterprise Linux is that you have to pay for that one. So then you can use there is a community clone called CentOS, which was basically a build of Red Hat Enterprise Linux that you could get for free. However, CentOS has really been deprecated, so now you have to use something called Rocky Linux, which is a little bit newer, but that's probably a good way to go. So I guess I would give you two options. I would say probably choose Ubuntu first, but if you really want something that's a little bit more enterprise based, or if you're trying to run the Quartus tools, which don't seem to work on Ubuntu, then you might go with CentOS. But I think I would go with Ubuntu if I were you.
That seems to have the widest support right now.
Yeah, and I always went to a place called distrowatch.com. You ever heard of that website? And it has a list of, it ranks the Linux versions by how many downloads they have, then you can pick what time frame you want.
Yeah.
And like you said, what you want is a popular one.
Yeah.
Because that way you're going to be able to get support.
If you're brand
obscure one.
Yeah, if you're brand new and starting out, I just go with Ubuntu.
I think you're right.
And with Ubuntu, pick the a long-term support version. So you'll see they have regular versions and they have LTS or long-term support versions. The LTS versions are supported for 5 years. And will be the ones that are not LTS are not necessarily going to be as stable and won't be supported for nearly as long. So I would choose Ubuntu 22.04. That means it was released in the year 2022 and in the 4th month. So
Nathaniel, aren't all the April ones LTS, or is it every other year?
it's all of the even years.
Even years, okay.
Even years. So the current one, and this is what I'm running on my systems right now, and I have actually been debugging with it quietly in the background for the past like 45 minutes. Yeah, jam and jellyfish. So right there.
Yep,
Scotty?
that's the one that I have.
Yeah,
Okay.
yeah.
Scotty, I got a question.
Oh, and if you really like being a little more classic, then you can go with Slackware.
You said Slackware?
Do not use Slackware.
I would not do that either.
That's what I was when I first started Linux. That's what I was told to use. I
Yeah,
was told
Slackware was new 20 years ago.
Nathaniel?
What?
Are you trying to set me up?
I'm just telling you the advice that was given to me when I first started. I was first told to use Slackware.
But you've learned so much, Nathaniel, that you won't do that again, right?
That's
You won't fall for that.
That's right. I actually
Scotty,
didn't
I got a
say-
question.
Okay, fire away.
I've been hearing everybody suggest using CentOS for the Quartus development. Has anybody tried it on Fedora?
I don't know. I mean, you can probably go to the support screens at Intel and Google that and see if
Okay.
someone is using
I mean,
it.
it's supposed to be the same stuff, more or less. It's
Yeah.
they're both Red Hat. Fedora is supposed to be the consumer version, not the enterprise version.
And it seems to me either Fedora or Red Hat was one of the original versions that they supported. And they supported CentOS forever, and then some other commercial version that you could buy and get support for. And I don't remember, it's been so many years. And then, of course, we all were crazy and we load Ubuntu and we tried to make it work under Ubuntu. And you could. We did. In fact, in 2013, I still have a machine over here that I built, that I made the 2013 version of Quartus run under Ubuntu. And it was painful, but it's like Nathaniel said, you Google it, you find people who have the problem and fix the problem, and then you fix it. And the problem back then was, even though you have a 64-bit computer, you have to load a bunch of 32-bit drivers because they hadn't really caught up yet, to full 64-bit.
Yeah.
So, and this stuff changes every year. So, and
I just thought it'd be interesting if Intel's supporting CentOS, the kernel and the support files are basically the same. The only difference is the enterprise versus the desktop.
Well, let me go.
Now, the other thing you're talking, I was looking at CentOS and
CentOS
getting it
doesn't
loaded on,
exist.
but Now that's been superseded.
Oh, yeah.
Yeah.
CentOS died last year sometime.
Yeah, you want to use Rocky Linux now.
Rocky or Alma.
Yeah, or Alma.
Well, I presume it'll be upgradable once we need to do that.
Not necessarily. You mean from CentOS to the new ones?
Right.
I wouldn't guarantee that.
No, they are making a commitment to like if you
There's
go
an
to
upgrade
Rocky,
path.
they're making a commitment to make CentOS upgradable to Rocky.
Oh, are they? Okay.
Yeah, because what Rocky's basically doing exactly what CentOS is doing, which is just to make a byte for byte, just a clone. They're just building the Red Hat
Yeah.
Enterprise Linux source code. And they're making sure they advertise as being bug for bug compatible.
Well, that's what you
Well,
want.
that's important
It is important. I agree.
because you want the workarounds to keep working.
That's right. So that is what they're advertising it to be. It's bug for bug compatible. And they're promising us it will be free.
So it says here on the Intel site that for Quartus Prime Pro and Prime Standard and Prime Lite, they support Red Hat Enterprise with Linux kernel 8.4 or 8.6, SUSE 12 and 15, Ubuntu 18.04 LTS, 20.04 LTS, and 22.04 LTS. But if you go scroll down, some of their other software is not supported under Ubuntu. So looks
But they
like
don't mention Fedora. That's interesting.
they don't mention Fedora at all.
Yeah, but wasn't that what it was? Is that CentOS is the only one that all the components that we need are supported?
They don't mention CentOS here either.
No, it's the Red Hat Enterprise. Red
Yeah,
Hat
that's the thing.
CentOS is Red Hat Enterprise.
Red Hat, okay. So is this, it says Linux 8.4 or Linux 8.6, that's the kernel revision?
No, that's the release version of Red Hat Enterprise.
Okay,
And CentOS tracked it. So their version numbers were the same.
okay.
But CentOS is gone. So I
But
don't
now
know
it's-
what the new ones are doing.
So,
Well,
but
it's
Red
not
Hat
gone.
Enterprise is
It's
still
that
there.
it's been superseded,
Well,
But-
that it's being supported.
it's the group that was CentOS has been sucked into Red Hat. They don't really exist anymore.
Okay.
The guy that founded, I think it was Rocky, was the original founder of CentOS. He split off and said, I'm going to do it again. Good for him.
Yep.
Well, this is interesting. It says that the Neos 2 embedded design suite is supported by SUSE 12 and Windows, and not Windows 11. Nice.
And that's the Quartus development, right?
That's the embedded processor.
Yeah, but the development version.
No, the Quartus is supported, but the embedded processor within Quartus is not supported. Yeah, this is the first I've seen of this, and I'm going like, okay, this is, I
Are we
think,
using that?
I'm using Windows.
No, but I mean, are we using the NIOS?
Oh, yeah.
Yeah,
Oh, yeah. Oh, that's what I thought. So lovely.
lovely.
Like Intel needs some software engineers.
Yeah, well, they need to make it run under Ubuntu. Come on, guys, the single most popular operating system, get with it.
No cheddar? It's the single most popular cheese in the world.
So do you have any cheese? Okay. Time to go.
Yeah.
Got my ballot all filled out, ready to
Oh, the cat's eating it.
walk down and manually deliver it to our voting place tomorrow.
Yes.
Don't forget to vote.
Nope.
I'm planning on it.
However you vote.
Right after the
good.
eclipse.
All right. So like,
Wait, Nathan, you said that you plan on forgetting?
No, I plan on voting. I'm going right after my 9 a.m. telecon tomorrow.
Oh, Lord.
Ooh, it sounds fun.
all right. We'll
It
see
looks
every-
like there's a hurricane headed toward Florida.
Yep.
Oh, not another one.
Hurricane Nicole.
Bullseye on West Palm Beach. Currently.
Oh my, oh yeah, Nicole, what's the projected? Oh, nice.
Actually, some would say that's a political target, but
Well, but take a look at the cone and where it's gonna hit Palm Beach. It's gonna turn right and it's gonna go right up the coast.
yep.
Nice.
Yeah, and they got another rocket on the launch pad.
Oh, that's right. They put it back out there. Oh no.
Put it in reverse. They just rolled that out this week, I think.
That's right.
Roll it back in.
Roll it back in. They're gonna wear out those crawlers.
All right. See everyone next week.
Okay.
Bye,
Have a good
everybody.
day.
Later. Thanks.
Take care.